So we have the last afternoon talk now, and our speaker is Boris Feigin, now from Israel. Please welcome.
Yes. Okay, so I can write and probably you can see. Yes, okay. So I will explain something about fermionic formulas. Yes, but first, well, about Tolya, I first met him long ago, actually in Leningrad when I had my PhD defense, but after that in Japan and I came to Japan actually for a long time every year, and almost all time Tolya was a part of Japan for me. And no, we talked a lot, went to Afura together, and well, and no, our interests intersect in many places, actually, almost completely, not all things, but almost all. And fermionic formulas is some important point. Yes, and again, so among people here who know Tolya longer than me, maybe Kolya Reshetikhin, the only person. Yes, so no, anyway, I happy to see Tolya at least by this way, and who knows, maybe we will meet after some time, but now we have this. Yes, and what I want to explain. No, in Tolya life, he returned to these fermionic formulas many times, and me also, and it is a very specific story about these fermionic formulas, but it is some kind of infinite process. They appear and appear and appear in mathematics for a long time, all century, and because of known or unknown reason. But first of all, what is this? No, what I can explain, my plan is explain what is this and what briefly what Tolya and other people did in this area, and what some kind of a story about these fermionic formulas which appear recently. And no, because I explained it is some returning process again, and again. Well, so let me start with a simple story. Fermionic formulas, no, again, they appear long ago, but most famous, no, maybe even this not the beginning, but it is Rogers, Ramanujan, and after Gordon identity, and this kind of formula, and Rogers and Ramanujan, they worked with the expression Qn square over Qn. It is this object is series in n, summation is going on by integer like this, and this symbol Qn as usual 1 minus Q and so on, 1 minus Qn. Yes, and there Rogers Ramanujan found that no identity that it is equal to something, but to formulate it, it is not important for me now, but such kind of expression, it has several properties and a way to get it. One, that in Q, if you look to Q as the as usual, it is a point of Poincare plane, then in this case, this expression is a modular form. No, it is first thing. Yes, and second thing, as a modular form, and it is not only the modular form. It means if we write this in tau and Q is some exponent of tau, then it had good properties if we make up SL2Z action here. Yes, so it means that this related in a sense with elliptic curves or something like that. Yes, and other things that it related with representation theory, and this is a serious point. It means that such kind of object is the character of representation of Virasoro algebra. We have of type and model of Virasoro. It is some no very specific representation of Virasoro, and in this model we have two representations, and the characters are given by this formula, and we can put n here also, and or not to do it, and by this way we get two representations. Yes, and no, the fact that this at least can be a character of something, that this is serious with the integer coefficients and even positive. If we have some expression where coefficient positive or negative, then the object can be difference of a character of something. Yes, and point 3, that we can get it by the following way. Let us take some current AZ, which is the sum of AI times Z minus I. And no, it is generating function of something, AI generator of algebra. Yes, and we suppose that AI are commute. Yes, and let us impose the condition that AZ square is 0. So it means that the sum of A alpha, A beta is 0. If alpha plus beta is some J. And I want to take the representation of this algebra. So what does it mean? This is commutative. I want vacuum vector killing by, say, A0, A1, A2, and so on. Because algebra is commutative, such part of algebra acting by 0, and other elements generate something. Yes, and because of this condition, it means that what we have is the polynomials in A minus 1, A minus 2, and so on, quotient by a consequence of this condition. And this condition, it means that we have to take this quadratic relation and factorize by consequence of this. it may be in a-1 square, and anyway, it is a sequence of quadratic polynomials, and next one will be a-1, a-2, and next, it will be quadratic things which follow from that. As a result, we get the character, we get some space, and on this space, we have two gradings. One is Q grading. It is, it is still this Q, it is Q grading, deck QAI is I, maybe minus I, is I, and deck Z of AI is 1. And so our space has two grading, and I can write a character, and the character will be the sum of Q n square Z over N over Qn. So we have such kind of expression, and also with Z. And no, it is important point. I will say soon how we use it. But before, if we are talking about generalization, no, we are talking about fermionic formulas, then in general, it means that we have fermionic formula is we have some algebra similar to what I presented, but it had not one generator, but many, maybe infinite, but for a moment, it will be, maybe for simplicity, let us take two generators, A1Z and A2Z. Now, in principle, it can be many, yes, and so maybe use here letter X. So they are, so in principle, they're similar. So the formal series which are acting somewhere. Yes, and this element algebra AIX, or we can say their component, they generate some algebra, and this generator, they satisfy some relations. I want to write this relation in terms how people are doing this in vertex operator algebra water language. Now, in our previous example, if I have a Z, I mean the situation when we have only what I discussed before in this Rogers-Ramanujan formula. So we have a Z, and it is acting in representation, what I presented before. And I have relation AZ square is 0. But how to say it, this, no, X, better to use X at least on this page. So I have a representation, what I consider, or maybe some different representation, but about representation, we have some conditions which follow from this. It means that if I have some vector from here, and if I replace AX1, AX2, and taking the scalar product with some covector. In representation, no, because in previous case it is relatively simple. The corresponding object usually calling correlation function, and this is function in two variables. Yes, and relation, from relation we can see what function we get. And this function, it will be first symmetric, and second f x1, x2 is 0 on the diagonal. So it means it has a form something times x1 minus x2 squared. Yes, and I use the language where we can say either we can say we have A and relation, or we can say that these elements are acting somewhere. We can considering matrix element or correlation function, and we are saying that this matrix element have some property, and this property is like this. Now we can say what is going on. That again I have A1, A2 in maybe X. Yes, and we have 2 by 2 matrix. In our case, symmetric. Say maybe A11, A22, A12, and A21. And we want to, what we want. So again, these operators are acting in some representation. And we want more or less the same things as before. So if I take A1, X1, no, AI, AJ here, X2, here again some vector and some covector, that this function has to be some function in variable x1, x2 times x1 minus x2 power aij. Yes, and yes, and no, it is details. Let us not to discuss it here. It is such things supposed to be symmetric. If I change I and j and x1 and x2, it has to be the same. So logic is going on like that, and in fact we have our generators AI, JX, and we can find quadratic relation. And if we impose this quadratic relation, then in our world, the matrix element satisfy such kind of formula. Yes, and so after that, we can take, no, suppose we do it. We have representation. No, again, no, just for example, so if we have, for example, matrix like this, what does it mean? It means that 0, it means that A1 is just commuting things. So from what I said, the matrix element has to be symmetric function, and A2 also. Here we have 1. It means that relation is A1, X1, A2, maybe, but same X here is 0. So it is from that. So anyway, my representation now is following. We have
Да,
some...
прошу прощения. Можете карандаш черный сделать?
А не видно, да?
Да, плохо видно.
Я, наверное, могу. если бы я знал как. Вот. Нет, пока она не хочет. А могу, наверное, вот. Вот так, да?
Да, отлично.
Вот. We have a representation R. My element AI. Yes, but AI M, its Fourier components. If I apply it to vacuum vector, it will be 0 if M is bigger than N, and then I take remaining things, AI -1, -2, and so on. I apply, and it gives me some representation. And about this representation, it has character. But this character, it has grading. It has Q grading as it was before. And it has Z grading. It means that, no, it is grading how many A's. So it means that, so A1 has Z1 degree, A2 has Z2 degree, and if we have many Z's. And the character of this space is functions in Q, and it is Z1, Z2, and Zn. So how many? How many particles we have? Particles, it is standard name for generators of this algebra, and I will use this. No, character is some function. No, this function, as I think, this is series in Q and Z, and it depending on metric. Yes, and this the formula which we get is a fermionic formula. And what is the structure of this formula? So in the simplest case, which we have one particle, and matrix was like this, then we have Qn square over Qn, Zn, and the sum of this. Yes, if we put, for example, 1 here, then it will be actually Q n square minus n over 2. But no, this linear term is not important for now, but so at least the element here determine the coefficient here. Yes, and if we have more generic story, then structure of the formula, if here it is one particle. If we have two particles, the structure is what? That we have here summation in n, here summation in n1 and n2. Downstairs we will have Qn1, Qn2. Here we have Q, and here it will be some quadratic expression, but let me write down the 1, Z, and 2. And in this place we have quadratic expression, and structure of this expression is following. The matrix which was before determined the quadratic form on two-dimensional space. And 1 and 2 gives me vector gamma of this two-dimensional space. And what we have here, no, it depends a little bit on notations, but how I said it is a scalar product of gamma gamma over 2. So it is possible to say that, well, the quadratic form is like this. Yes, now let me explain what, no, again, why it is important, and probably what was it? One additional element that, so by this way, we get series which pretend to be a character of something. Or we can make up a little bit smaller, no, little bit smaller space. In a case when we have one particle, we can do the following. We can take our space, which is like this, and we can cut it. We can do it by many ways, and it's interesting, but simplest way, we can factorize it by a minus n plus 1, and so on. Now, it gives us the quotient, and if you want to calculate the character of a quotient, it is similar story, but and also summation. But so what the structure of this formula? You have Q, you have quadratic form here, some Z, and here we have these things which sometimes calling almost calling Q factorials. If you make up the quotient structure of the formula, I have no time to describe it in details, it is not possible. But Q factorials we have to replace by Q binomials or Q, or some version of Q binomials, and it gives you fermionic formula for such quotient. Then what people, excuse me, what people like Tolya did it. So because of some reasons, it is possible to formulate the following problem. Well, suppose we have some finite dimensional algebra G. It is interesting, even if it is L2, we have finite dimensional representation, and we can take tensor product of several of them. In this case, it is some kind of story. So if we have just a reducible representation, we can attach to it character or Q character or just character. It is some function or polynomials that on Cartan. On more subtle things, it is Q character. It is Q character. It is some function depending in Q, and also something from Cartan. Yes, and if Q is 1, it is what we had before in the character, but with Q, it is something, and some interesting things, and usually what people are doing. So we have representation, and if we calculate character, we take trace of element, say H from Cartan, and this. But if you have Q character, we introduce some filtration on natural filtration. In principle, it's not unique. It's very interesting way to do it. But we want to have some natural filtration, and yes, so we can, if we have filtration, we can form a joint space, and the character of this joint has additional grading or additional commutative algebra, which is acting here. And so after that, we have Q character. So people are doing this, or it is possible to do similar things. We have many representation. We can decompose it. It is a sum of irreducible representations with some multiplicity, and there are surely some combinatorial or other formulas for these things, but it has also Q versions. Such kind of Q versions appear from different places, and one place is lattice model. And this was a reason why people like Tolya, one of the reasons, not unique, why people like Tolya studied Q version of this. And famous formulas of Kirillov and Reshetikhin are solve this problem, not in general, but in many cases. And they actually, among other things, they wrote fermionic formulas for this quantity. So this is, no, it is not a simple formula, but very useful. And also some, as a story, let me say only example without big explanations. Suppose we are talking about UQ of SL2 hat. Now it is not G is SL2, but I considering this. And Q, it means that it is quantum group, and the corresponding problem, no, it is different Q surely, but it is standard usage it here. Yes, and I want to consider a root of unity. It is 1, and it will be 5. In my case, and I take simplest two-dimensional representation. And after that, I take a tensor product of them in several copies. And no, because it is quantum group tensor product, we can understand in some a little bit non-standard way. This I also do not want to do, but it is some kind what we can call fusion product, tensor product. So it is some version of tensor product, and we can decompose it. Yes, and again, we have some space of multiplicities, and we also can ask, it is some different way to define the Q character of it, or Q dimension maybe. So what we are doing, we decompose first, take multiplicity space, and this multiplicity space is some finite dimensional space with depending in n, and we can write down the Q dimension of it. Yes, and for this Q dimension, no, first of all, from other different stories, either from conformal field theory or from XXZ models or from quantum groups. It depends who is doing this. We can make up this Q character, Q dimension. So it depending on n, and little bit depends on it is multiplicity of what? Yes, and the story is that if n is go to infinity, then such kind of character, it is polynomial, but n is going to infinity, it gives us some character. And in this special case, we get the character of representation of Virasoro from 2-5 models. And corresponding expression will be just Rogers and Monodjan expression, which I explained to you. Yes, and no, well, no, as usual, I cannot say much, but let me try to explain what direction is going on after that. So one thing that what people do, one story, we have a representation of some algebra, for example, Virasoro, or some other vertex operator algebra. Yes, and the minimal model or some other representation are, they have some character. And it was big challenge till now to find out the fermionic formula for such representations. And the hope was that if we know such kind of fermionic formula, we after that we can find a way to get this representation by some procedure of thermodynamic limit. So it like before. So I started with very different object, the tensor product of representations of, for example, baby quantum group. I find here multiplicities, then n go to infinity, and I can find in principle at least character of Virasoro 425, an example. And character, yes, and some kind of challenge to find out in this business real Virasoro, so how to do it. And this problem is very important. It is not solved till now, but people are working about it. It is one element of a story. Other element of a story, this is, no, well, and again, I want to say that Tolya was involved in this business, and he had even here some good results, not only about the characters of multiplicities, but here also. Other things what related to Tolya business, we know that if we have, for example, a link or not, or M3, three-dimensional manifold, or something like that, that following the construction, now in this case, maybe something like Reshetikhin Turaev, for the links, it is also they and other people, like starting with Witten, but we can construct the invariant of such things. If it is a link or not, we can produce some function which is invariant of a link. We need to have some Lie algebra, and in this case, it will be something depending in Q. And people are doing what? That in principle, they have these things depending in many variables. If you have here JLN, so we have invariance depending in N, and if it is possible to make up analytical continuation in N, and so we get some invariant like this. Yes, but it is not only that, if you are talking about Havanov invariants, which at least for links are well defined, but with some problems, that
gives you some function depending in T. Yes, and people also saying that if you have all this related for some Lie algebra, and if you have some representation of Lie algebra, you can color it not by this representation, it is also depending on that. Anyway, we have such kind of things, and one element of a story is that we can try to write down fermionic formula for that. And if related to Tolya business, he had some nice things about that related with some notes, and he worked with toric notes, but not only probably. Anyway, he had he one of the pioneer of this business because such kind of things. And again, the one conjecture based on maybe some physics or some other things, that such kind of things, they exist fermionic formula for that. And if it is fermionic formula for that they expect it to be the character of something. And but characters are characters of some representation of vertex operator algebra or some quotients, and they really appear here. And if you are talking about a three-dimensional manifold, the situation is much more subtle, and here all what we have, in principle, it is conjectures. But if you have M3, then we can produce some function in Q and maybe many other variables, and at least in some cases, there such kind of invariant is also given by fermionic formula. Yes, and in principle, now the level of this science is falling, that it is some kind of machine which at least working by the following way, that it is machine, here you put link, and here it gives you the fermionic formula. So it produces sometimes very, very big matrices, and fermionic, it gives you such kind. No, in fact, if you give a link, you can construct many matrices, but the character will be the same. So it is very, very interesting story. And it's so how, no, I have 15 minutes, am I right? Oh. Oh.
Yes.
Yes, yes. So, no, I want to no, in the very end, I'm sure can I or not to present some kind of, no, there are some old formulas and some new formulas in this business, but let me say about the third area where such a kind of formula appear. Suppose we have some kind of model space, and in modern physical language, it can appear as a modulus space of something, some kind of bundles on a curve or something like that, or they can appear as branches Coulomb branch or Higgs branch or something. Now, if we have some kind of interesting modular space, sometimes in most of cases, it's equipped with the action of torus, and we can take some bundle, linear or not, for example, functions. O it is Schiffer function of this modular space, and because T is acting, we can write Euler equivalent Euler characteristic, and it gives us some kind of interesting function. And again, not always, surely, but in many cases which I know, this function exists fermionic formula for this function. For example, the good and maybe some well-known, not a well-known example is following. Suppose we have a group, this group, Lie algebra, better to have simpler list, JLN, for example. Yes, and in this case, we can construct the object which appear by this way, which are calling by the star. And so they are actually appear in as a transfer. There are many definition and not a good way. So you have to believe, and maybe people know it. It's some important manifold, and they appear as transversal slices in a fine Grassmannian. Or alternatively, you have a flag manifold and consider maps from CP1 here with a fixed topological number. And so we have all maps to here with some condition. It is not for now, but this manifold depending on topological type of this. So it depending on two-dimensional class of homology of F. Anyway, you can take such manifold and ask about this question. Yes, and no, people interested by this, or sometimes they are changing the shift, but what is this? No, the structure of formula is, again, I do not write it in the full details, but if you want to write down the fermionic formula, you need to have this matrix, which was 1 by 1 or 2 by 2, and what I discussed. But here it is big one, and structure is following. So we have JLN, so we have Cartan matrix. It is 2, 2, 2, minus 1, minus 1, minus 1, minus 1. And additionally, we have some infinite dimensional matrix. So it is Cartan, it is C, and it infinite dimensional matrix, which we call G, infinity. G in because it's related with Gordon identity. And it has a following structure. It is 2, 2, 2, 2, 2, 2 here, then 4, 4, 4, 4, 4, 4 here, then 6, 6, 6, 6, and so on. So it is going like this until infinity. So here only even numbers. And our matrix is tensor product of this times this. No, it is big matrix, but the fermionic formula for O, it is, you know how to say, no, I do not want to write down very precise things because no, it is not very complicated, but I need notation, which I do not introduce, but roughly it means the following. You write down the summation which are corresponding to these matrices, but so no, it is infinite. So here you have some up by huge letters, but in this summation you have to choose some subregion which depending in what manifold, what in topological numbers, and so you have, because it has to depend on this data. Yes, if this data go to infinity, then a corresponding formula has a limit, and it gives us the full fermionic formula. And in this case, it is this one. Yes, and I want to say about this, to add maybe two things. That again, if you are considering this specific formula with this matrix, in principle, this matrix, it appears in all questions which I discussed. One question is if you want to write down the characters, fermionic formula for characters for Virasoro representation for the minimal model for JLN, actually what you are doing, you have to operate with this formula and also make up some kind of summation by some subset of gamma. And but it's more complicated. Sometimes you have to replace by Q binomials, but it gives a formula of such type. Second, you can find out such kind of formula if you studied links or knots, and such kind of things appear in this business. Again, third things, what I said, it appear how I explained. So if you have a model space or this Higgs branches or modular space of something. By the way, this Lamont space or Zastava, it is similar things, appear as branches of something. So this is one of the main examples which people are interested in. The fact that such kind of calculation of such kind of manifolds or things like that related with links and so on, it is deep story, and maybe I have time only mention some kind of calculation which related with all what I said, but maybe slightly more concrete. That you can take quantum group UQ of JLN, for example, and you can take some representation, maybe W1 times W2 times so on times Wn. Yes, and on this representation is acting, no, because it is quantum group, we have R matrices and colored, no, if this representation identical, then braid group is acting. And if they are different, that colored braid group is acting here. You can take some element gamma from this, and you can ask the question. I have gamma acting here, and the question is, can we find the trace of it? And trace, depending on the choice of these representations and choice of gamma. Actually, no, I mentioned it because of two things. That the problem with Tolya started in some of this work, which I remember. He started this question which lead to invariance of toric knots. But this is surely the question which you can ask in general. And the question is to find out fermionic formulas. No, to find out what is this. Any formula for such kind of things is interesting. It is some kind of function which, depending on the choice of representation, and this parameter q here, and surely of this. And then it's good to write down some formula, or in some cases, it can be not trace, but matrix element of this. And about this story, let me say maybe a last statement and stop. About this, the story is following. I can take a quantum group, UQ, maybe JLN, maybe some other, and it is Fermat representation of it. So it depending in highest weight, say chi. And inside of this representation, we have some specific vector, W, which is calling Whittaker vector.
1 minute.
Yes, it is a Whittaker vector, and we can calculate such things with graded element here, and people, it is standard construction of eigenfunctions for Toda system. And what I want to say is that formula for eigenfunction is just fermionic formula what I wrote for this method. And I like to play with it because on Fermat representation, according to Lustig, is acting colored braid groups, and we can put here also some element from this braid group and get some version of it now depending on the braid group. Here from Lustig, and it will be some kind of interesting function, and it is fermionic formula for that either. Again, matrix is the same, but summation or what with subtlety, how we sum up, matrix is the same, but summation depending in G. And this is interesting story, and I think I know some formulas, it is new things, and probably it's never written till now, but at least it is how it is going on. So excuse me, I have to stop. Yes. Oh.
Thank you. Questions?
Боря, привет, это Коля Рештихин.
Привет, привет, привет.
Boris, I was listening to you and I was wondering about the portraits.
I do not hear, unfortunately. Oh.
The portraits.
Oh.
Okay. Can you hear? Hello?
More or less, try.
Who are the people on the portraits behind you?
No, it is good question. It is Jerusalem, and I found some book with such kind of pictures. They're Flemish, old Flemish painters, and I just put it on the wall. So,
I
so
thought just behind you is
no, I have many. For example, this one, or this one, or this one. You see.
Good.
And in other rooms also, but maybe I will not show you anyway.
Boris, thank you very much. Wonderful talk.
Oh.
I have too many questions, so I'll ask you.
No, I understand. No, Cole, maybe we can talk sometime. We stop to do it, but I hope we can do it again in some time. We have many things to talk about this or about other things. Okay.
Thank you.
Oh. So bye and.
No questions? Maybe no questions. Thank you.